Our knowledge of the cosmos originated several thousand years ago with our early ancestors, who utilized the stars as a pathway through the wilderness and a calendar for the flow of time. Roughly 4,000 years back, the ancient Egyptians were among the pioneers to devise an organized system of astronomy, which played an integral part in their daily lives. They based their agricultural activities, religious rituals, and even governmental decisions on the movements of celestial bodies, demonstrating an advanced comprehension of stellar patterns. These early Egyptians also left a lasting legacy in the form of awe-inspiring structures, like the Great Pyramids of Giza. The construction of these monumental edifices was not only an architectural feat but also a testament to their knowledge of astronomy. Meticulously planned and erected, the pyramids were then just burial sites. They were cosmic diagrams encoded in stone and aligned with precise celestial points. The Pyramid of Khufu, for instance, has shafts pointing directly to the belt of Orion and the brightest star, Sirius, a remarkable testament to their prowess in ancient astronomy. The alignment of these pyramids with specific stars, therefore, demonstrates their profound understanding of the night sky, as well as the significance they placed on their relationship with the cosmos. Delving deeper into the annals of history, we journey back to the pivotal age of the ancient Greeks. Circa the 4th century BC, the influential philosopher Aristotle made a groundbreaking announcement suggesting that the Earth was spherical, not flat. This wasn't just a simple geometrical correction, it fundamentally altered the way we view ourselves in relation to the cosmos. It sparked intense debates, provoked thought, and changed the trajectory of astronomical studies. While the society grappled with this new understanding, another Greek genius, the mathematician and astronomer Aristarchus, put forth an equally revolutionary idea. He proposed that the Earth was not at the center of the universe, but rather, it revolved around the sun. This heliocentric model was, however, a radical deviation from the widely accepted geocentric model that had been entrenched in their society's belief system. The notion of a static Earth at the center was deeply ingrained, and Aristarchus's idea threatened the established thought that had been prevalent for centuries. Despite the brilliance of his theory, Aristarchus faced substantial resistance due to the absence of empirical evidence and the inability of the Greeks to observe the apparent yearly motion of the stars, which his model predicted. His heliocentric theory, sadly, did not gain mainstream acceptance until much later, when technological advancements facilitated better astronomical observations. The astronomical theories born in ancient Greece laid the foundation for our space exploration journey. Their impact extended beyond scientific realms, permeating societal beliefs and spurring philosophical discourses. These ancient Greek theories served as the basis of our understanding of the universe and continue to influence the way we study it today. Jumping ahead to the 16th century, we witness the groundbreaking work of a man named Nicholas Copernicus. Born in 1473 in the Kingdom of Poland, Copernicus was not just an astronomer. He was a well-rounded polymath, a mathematician, a doctor, a diplomat, a jurist with a doctorate in canon law, and even an economist. In a time when most people believed that the Earth was the center of the universe, Copernicus dared to challenge this long-held belief. He reintroduced the idea of a heliocentric universe, a universe where the sun, not the Earth, sat at the center. This concept was not new, but an echo of theories proposed by ancient Greek astronomers. However, in the era of the Renaissance, this idea was nothing less radical. It was met with resistance, scorn, and even ridicule. Copernicus's heliocentric model was perceived as a direct challenge to the theological and scientific beliefs of the time. It stirred controversy, not just among religious authorities, but also among fellow scientists and astronomers. But what was revolutionary about Copernicus's work was his dogged perseverance. Despite the criticism, he held steadfast to his beliefs. He continued to refine his model, making detailed observations and calculations that gradually ironed out the inconsistencies and flaws in his initial theory. As time wore on, the evidence supporting Copernicus's heliocentric model grew stronger. The publication of his book, On the Revolutions of the Spheres, shortly before his death in 1543, was a turning point. Despite triggering a wave of condemnation, it also ignited a spark of curiosity. In the following centuries, the work of others such as Galileo Galilei and Johannes Kepler further validated Copernicus's model. They expanded upon his work, providing empirical evidence that would eventually lead to the broad acceptance of the heliocentric universe. This story of Nicholas Copernicus serves as a powerful testament to the profound impact that one brave and determined individual can have on our understanding of the cosmos. His assertion that the sun, not the earth, was at the center of the universe set the stage for future astronomical discoveries and forever changed the way we view our place in the universe. Our journey takes us to the pivotal era of the 17th century, a time marked by the invention of the telescope by the celebrated astronomer Galileo Galilei. This was a watershed moment that completely redefined our interpretation of space. The telescope, a remarkable innovation of its time, was not just an optical instrument, but a window to the unexplored cosmos. It was instrumental in unveiling the vastness of space and its countless celestial bodies. Galileo's simple yet powerful invention allowed humans to observe the celestial bodies with an unprecedented level of detail. This tool, which magnified distant objects by bending light, paved the way to discover celestial wonders that had been elusive to the naked eye. It provoked a seismic shift in our comprehension universe and our place within it. One of the landmark discoveries made possible by Galileo's telescope was the existence of the moons of Jupiter. This was a breakthrough that shattered the geocentric model, which suggested that all celestial bodies revolve around the Earth. Upon observing Jupiter's moons, it became apparent that other bodies in the solar system also served as the center of motion. Additionally, Galileo's telescope brought the phases of Venus into sharp focus. This observation lent further credence to the heliocentric model, which purports that the Earth and other planets revolve around the Sun. These revelations, made possible by the Hubble telescope, laid the foundation for the future of space exploration, shaping our quest to understand the mysteries of the cosmos. The dawn of the 20th century heralded an exciting age of space exploration. The real leap forward, however, came in the year 1961, when a former Soviet Air Force pilot, Yuri Gagarin, would forever etch his name into the annals of history. Gagarin, in the spacecraft Vostok 1, became the human to journey into outer space and orbit the Earth. This epical event was a culmination of several years of meticulous planning and rigorous training. The world watched with bated breath as Gagarin's spacecraft lifted off, pushing the boundaries of what humanity believed was possible. The era of manned space exploration had just begun. It was a time of heightened anticipation and competition between two superpowers, the United States and the Soviet Union. It was within this charged atmosphere that the USA was plotting its own monumental mission. Fast forward 8 years to 1969, American astronauts Neil Armstrong and Buzz Aldrin were preparing to take a giant leap not just for America, but for mankind. Armstrong and Aldrin were to be the first humans to set foot on the moon, a feat that was to be accomplished under the historic Apollo 11 mission. Their journey was not without its challenges. The astronauts had to endure rigorous training as well as the pressure of potentially being the first humans on the lunar surface. As Armstrong stepped onto the moon's surface, his iconic words, "That's one small step for man, one giant leap for mankind," echoed across the world, symbolizing a triumph not just for the United States but for all humanity. The successful moon landing marked a new chapter in space exploration, opening up a frontier of endless possibilities. Thus, Gagarin's and Armstrong's historic journeys stand as testament to mankind's unwavering desire to explore the unknown. In the 21st century, our exploration of space has taken a dynamic turn, with private companies stepping into the limelight. We've launched numerous probes and rovers to other planets, but now, it's not just government organizations leading the charge. Private companies like SpaceX have started to play a pivotal role in space exploration. They have revolutionized the industry, bringing about an era of commercial space travel. Their contributions have been instrumental in pushing the boundaries of what's possible, leading to unprecedented advancements in technology and science. Among the major achievements of these private companies, SpaceX stands out. SpaceX has been a game changer. It is the first ever private company to not only send a manned mission to space but also to dock with the International Space Station. Moreover, Their Falcon Heavy launch was a monumental step towards making space travel more accessible and economical, as it's designed to carry large payloads at a fraction of the conventional cost. Furthermore, SpaceX's Starship is being developed to carry humans to Mars, opening up the possibility of interplanetary colonization. Through these groundbreaking achievements, companies like SpaceX are redefining the future of space exploration. So, are you curious to know more about the most astonishing facts we've discovered from our deep dive into the cosmic world? Well, let's start with the eerie silence of space. Did you know that it's completely silent out there? The absence of air in space makes it a vacuum, and without a medium, sound cannot travel. So the exploding stars, crashing asteroids, and blazing comets are all but noiseless displays of cosmic art. Next, consider the gradual deceleration of Earth's rotation. Yes, you heard that right. The speed at which our planet spins is slowing down infinitesimally each day. This phenomenon, caused by the gravitational interaction between Earth and the Moon, means that millions of years from now, our days will stretch longer than the standard 24 hours. So in the distant future, you'll have more time in a day, quite literally. Here's another mind-boggling fact. There are more stars in the universe than grains of sand on all the beaches on Earth. Now consider the billions of beaches around the world and the innumerable grains of sand they host. The number of stars out in the universe eclipses that dramatically, a testament to the vast, expansive nature of the cosmos. Lastly, let's talk about the footprints left by astronauts on the Moon. Thanks to the Moon's lack of atmosphere, there's no wind or water to erode them. This means that the footprints, the flags, and the tire tracks left by lunar rovers will likely stay for millions of years, standing as silent testimony to humanity's first steps into the broader cosmos. But that's not all. Space also extends and in size. Yes, the universe is constantly expanding, creating more and more space and moving galaxies farther apart. Additionally, did you know that if you could drive straight up, you'd be in space in less than an hour? The internationally accepted boundary of space is just 62 miles above us, known as the Kármán line. These astonishing facts only highlight the vastness and mystique of space, but also underscore the significance of our ongoing efforts to delve deeper into the cosmic expanse. Every new discovery reveals more about our place in the universe and unravels the fundamental truths of existence. Our journey of space exploration is a tale as old as time, starting from our earliest ancestors who gazed up at the night sky, fascinated by the twinkling celestial bodies. With no understanding of the cosmos, they mapped the positions of the stars, forging constellations out of the randomness, sowing the seeds for the science of astronomy. This interest in the stars grew over the centuries. The ancient Greeks established the geocentric model, placing Earth at the center of the universe. But it wasn't until the 16th century that Nicholas Copernicus presented the heliocentric model, proposing that the Earth and other planets revolve around the sun. Fast forward to the 20th century, the launch of the first man-made object into space, Sputnik, marked the dawn of a new era. This was quickly followed by the first manned spaceflight by Yuri Gagarin, and then the unforgettable moment when Neil took mankind's first steps on the Moon. In the present day, our understanding of space continues to grow exponentially. With advanced technology, we've been able to delve deeper into the cosmos, exploring distant galaxies and black holes. Instruments like the Hubble Space Telescope and missions like Voyager have opened our eyes to the vastness of the universe. As we look to the future, the journey of space exploration continues to promise exciting possibilities. With plans for manned missions to Mars and the prospect of colonizing other planets, our understanding of space is poised to take leaps and bounds. The search for extraterrestrial understanding dark matter and the possibility of interstellar travel are just some of the intriguing prospects. Our journey from tracing the path of stars to potentially setting foot on other planets is nothing short of extraordinary. As we continue to push the boundaries of our knowledge, we gain a better understanding of our place in this vast universe. It's a truly fascinating journey, one that we're all a part of.